I was staring at a loading screen the other day. Uh, I'd asked this AI agent to do a pretty complex multi-step research task.
Yeah.
And I just sat there.
Just watching a little icon spin.
Exactly, just watching it spin. And it hit me right then that, the ultimate bottleneck for our future isn't really the software anymore. It's the physical silicon.
Hmm.
So today, our mission for this deep dive is to unpack OpenAI's groundbreaking new custom chip.
The one code name Jalapeño.
Right, Jalapeño. And we're going to look at how they are engineering this incredible full-stack strategy to make AI widely abundant, instantly available, and just incredibly efficient.
Because that loading screen you mentioned, that is the exact wall the entire industry is hitting right now.
Yeah.
We are moving from AI that, well, just types out simple text answers to AI that actually executes continuous actions.
Right. Across all these different applications.
Exactly. And that shift, it requires a totally different scale of hardware performance.
But historically, hardware architecture kind of forces a brutal compromise, right?
Yeah.
You usually have to pick your priority.
You do. Chip designers generally have to choose. It's like, do you want massive throughput?
Which means processing a huge mountain of data simultaneously.
Right. Or do you want low latency, meaning lightning fast, instant responses?
Yeah.
To maximize one, you almost always have to sacrifice the other.
Okay, so I'm a little confused here then, because the InferenceX benchmark results on Jalapeño, they show it delivering up to 3.6 times lower latency, while simultaneously getting almost twice as much AI work done per watt. Like, how is it doing both at the same time?
Well, the secret is really in how the architecture handles memory.
Okay.
Traditional chips waste a huge amount of time and electrical power just shuffling data back and forth between the processor and these separate memory banks.
Ah, right.
So Jalapeño reimagines that physical layout by bringing the memory directly alongside the compute cores. It essentially just eliminates the commute for the data.
Which slashes the latency and the power consumption all at once.
Exactly.
Oh, I see. So instead of a master chef who just magically chops vegetables faster, it's more like completely redesigning the commercial kitchen itself.
Yes, that is a perfect way to visualize it.
The chef doesn't have to sprint to the walk-in fridge for every single ingredient because the exact spices and produce they need are built right into the prep station.
Right. And when you eliminate that friction at the hardware level, the sheer volume of tasks an AI agent can execute seamlessly just skyrockets.
Which actually brings up a really great point for anyone listening who wants to harness that kind of speed. I want to give a quick shout out to our sponsor, Silk. If you need help with AI training or automation, integration, or even software development.
Basically trying to figure out where agents can make an impact.
Exactly. For your business or your personal life, you definitely need to check out embersilk.com for all your AI needs. So getting back to this hardware leap, designing a fundamentally new chip architecture with that level of efficiency, that usually takes years.
It does. But OpenAI went from initial concept to tape out, which is when the final design is sent off for manufacturing in just 9 months.
Wait, pause. 9 months. I know AI can write like Python code for a website, but how do they use AI to design the physical hardware? How does software write a physical object?
Well, at a fundamental level, modern chip design relies on hardware description languages.
Okay.
It's essentially code that dictates how electrical signals will move through billions of microscopic transistors.
Wow.
So by utilizing models like Codex and EPT-Astra, the AI treated those physical silicon pathways like lines of code.
Oh, that makes sense.
Yeah, and it identified complex routing efficiencies and, logic optimizations that human engineers simply couldn't spot.
That is wild. Are we literally watching AI accelerate its own evolution in real time?
We really are. In some of the core architectural blocks, the AI-generated implementations ran 1.5 to 1.8 times faster than the human-written versions.
That is incredible.
Yeah.
But a chip is still just one piece of silicon, right? It doesn't run in a vacuum.
Which is exactly why OpenAI is moving to this full-stack strategy Sarah Fryer talks about. They aren't just dropping Jalapeño chips into old, inefficient server racks.
Right.
They are co-designing the entire ecosystem, the models, the software, the networking, right down to the physical data centers themselves.
Like Project Camellia down in Georgia.
Yeah.
That facility is so fascinating.
It really is.
It's a purpose-built data center that creates all these local jobs. But what really caught my attention was the environmental engineering part of it.
The closed-loop system.
Yes, specifically the closed-loop water system. Because normally, traditional data centers consume millions of gallons of fresh water.
Right, by evaporating it to cool the hot servers down.
Yeah, But a closed-loop system acts more like a giant radiator.
Mm-hmm.
It continuously circulates the exact same water, absorbing the heat and cooling it down without evaporating it into the atmosphere.
It's a brilliant piece of sustainable infrastructure.
Yeah.
It protects the local water tables while still sustaining massive computational power.
Which is so inspiring. And this all ties into the Jevons paradox, which I find incredibly optimistic for our future.
Oh, absolutely.
Because the paradox states that as a resource becomes highly efficient and cheap, like AI computing power will be with Jalapeño.
Right.
We don't just use less energy and call it a day. The drop in cost sparks an absolute explosion of new innovation.
Yeah, when you lower the barrier to entry like that, human creativity just takes over.
Exactly. We are going to see businesses and individuals using these powerful, affordable AI agents to tackle complex scientific and logistical challenges.
Things that were previously just way too expensive to even attempt computing.
It is truly a tide that lifts all boats. So here's a final thought for everyone to chew on.
Mm-hmm.
If AI is already treating silicon pathways like code, finding routing efficiencies human engineers missed, and optimizing its own hardware in just 9 short months.
Wow.
Just imagine the miraculous solutions and physical infrastructure it is going to help us engineer in 5 years. The future of human progress is looking remarkably bright.
It really is.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.